So here we go. Hello everyone, I am Michał Bentkowski. You may know me as SecurityMB from Twitter. And in this live stream, I'm going to talk about parsing and serialization of HTML, why it is quite crazy, and how it could lead to bypasses of the popular HTML sanitizer library called DOMPurify. So there's a lot to cover today, so without further ado, let's begin. Okay, so this is recorded live, so if you have any questions, you can ask the questions in chat and I will answer them. Okay, so let's begin with some setup, what we are going to talk about today. So we are going to be focused on the so-called HTML sanitizers. So certain websites usually using the rich editors or WYSIWYG editors, users are allowed to enter some HTML in a page. So for instance, here I have a very simple page where I can enter my profile info. So I can say that my name is Michał and Michał can be bold. And as you can see, this HTML is rendered right below. Now, while we want users to be allowed to enter some HTML, to format text, to add some images, and so on, we don't want them to be able to enter some HTML that leads to cross-site scripting. Like in this example, I added the image tag with the onError attribute and I have the alert executed. So to allow users to enter HTML but disallow the harmful HTML, we have some libraries that are collectively known as HTML sanitizers. An example of this kind of library is DOMPurify. This is a very popular HTML sanitizer written in JavaScript. And well, let's see how it works. So I'm going to copy its URL. Then I'm going to add another script with DOMPurify. And well, instead of assigning the HTML directly to inner HTML of the div, I'm going to call DOMPurify sanitize before. Maybe I will make it slightly wider. Okay. And now when I try to input, like my name is Michał, well, the bold is still here. But when I try to enter the cross-site scripting payload, well, we can see that the image is shown, but the alert one did not execute. And if we have a look at the DOM tree, then it is quite clear that the onError attribute was stripped from the markup that I entered. And this is the basic idea of HTML sanitizers. That is, they iterate over all elements and attributes in the HTML or in the DOM tree and delete the ones that are deemed to be dangerous. Basically, most HTML sanitizers have allow lists. So they have an allow list of attributes and an allow list of elements. And if something is not on that allow list, it is deleted. Okay, so in this example, we have DOMPurify, a slightly older version, like the version from last year, I guess. And well, the problem is that we have the DOMPurify plugged in here, but I can enter some magical payload, like I can open the math element, then mtext, then form in the beginning, then I close the form, then I start the form again, then I add mglyph, and then I add, let me think, style, and then image with the onError attribute, and suddenly I have the alert executed. So even though I'm using DOMPurify, I still have a way to bypass it. And well, this is a huge problem because well, our protection against cross-site scripting is bypassed in this case. Of course, this is an older version of DOMPurify. This particular payload is fixed in the most recent versions. How this payload works? Well, we are going to talk about this in detail in this stream. So from now on, to show you all these examples, I'm going to use a page that is called live.dom++. I wrote it to make it easier for myself to research the security of various sanitizers and HTML parsers, but it is public. I will paste the link in the chat. The basic premise is that I can enter some markup and I can see how it is parsed into a DOM tree. So we can clearly see what the browser is doing in this case. Also, I can set that I want to use DOMPurify in here. Maybe I will set to version 2.0, just like before. And now when I enter some markup, let's say that I will use the XSS payload, we can see how the DOM tree looks before sanitization. Then how looks the string that is returned by DOMPurify sanitize. And then we can see how this string that DOMPurify returned looks as a DOM tree. So we can clearly see that the unerrored attribute that was in the DOM tree in the first place was deleted by DOMPurify. Okay, so I'm going to talk about bypasses for DOMPurify, but before going into that topic, we need to cover HTML parsing and some, crazy features of HTML parsing. I'm just going to answer one question on chat. Okay, and maybe I will go back to the DOM parser. So we are going to talk about two operations, so parsing and serialization. And parsing is what we see right now. So I enter some markup, and then this markup is parsed, and it is parsed into some DOM tree. However, we can do it the opposite way, so we can change the DOM tree into some kind of markup. I'm going to do this, so I'm going to enter the parsed DOM tree into a variable. Okay, so I'm going to display doc, and then I'm going to display how it is serialized, which I can do with the outer HTML of document element. Okay, and let's assume that I am going to add some div in here with class attribute, which is equal to ABC. Now, the first thing to notice in here is that the serialized markup is not exactly the same like the initial markup. For instance, I didn't have the HTML or head or body tags in my markup, but they were added automatically. And another difference is that I used single quotes in the value of the attribute class, but after serialization, the single quotes were substituted with double quotes. Well, basically, the algorithm for serialization says that always the values of the attributes are enclosed in double quotes. Okay, so let's move on and let's talk about foreign content. Okay, so basically every element in HTML, or every element that is yielded by HTML parser, has a namespace. And by default, as you can see, the namespace for all elements is HTML. And if we don't think about it, and if we don't do something unusual, then most likely HTML namespace is the only one we are going to see. However, there are two elements that can be created in different namespaces. So the first one is SVG and the second one is math. And as you can see, SVG is not in HTML namespace, but in SVG namespace, and math is in the Mathml namespace. And what is interesting is that the parsing rules are quite a bit different in those two examples, because certain elements that have special parsing rules in HTML don't have the special rules for foreign content, so for SVG and math. So let's see a simple example. I have a style element, And let's say that I want to add a child element for style. So I have an anchor and am I a new element? Well, even though the inner text of style looks like a snippet of HTML, like some text like some markup, it is actually treated as text. And this is how the HTML specification specifies the style element, that it can only have text. However, when I open a foreign content, so for instance SVG, and then I try create a new element, in this case, I can just copy this, then it is parsed differently. Suddenly, the style element can have child elements, which was not possible in HTML. So the parsing rules for elements are dependent of the namespace. So style in HTML namespace is parsed differently than style in SVG namespace and than style in Mathml namespace. There's another difference that is worth mentioning. And so let's say that I add an HTML entity in the style that is in HTML namespace. And as you can see, the entity &lt is not decoded. It is treated just verbatim. However, when I do the same in the foreign content, then the entity is decoded. So basically, all those special parsing rules that happens in the HTML are no longer true in foreign content within SVG or within Math. And it turns out that foreign content is extremely useful in bypassing various sanitizers, but we will go back to that. So by default, all elements have HTML namespace. If we want to switch namespace for HTML to anything else, we can use either SVG or Math. And if we are inside SVG, then also all elements by default inherit the namespace of their parent. So if I create an A element within SVG or a canvas element within SVG, then it is in the SVG namespace. If the canvas was before the SVG, then it is in the HTML namespace. But there are certain exceptions. So we have a special element in SVG, maybe I will Google it. So SVG Foreign Object. There is a special element in SVG that is called Foreign Object, whose purpose is basically to include elements from a different namespace than SVG. Okay, and well, let's have a look. So I'm going to add the foreign object in here. And then children of foreign object will have the HTML namespace. So this is basically a point that we can switch namespace from SVG to something else. And this is called in the HTML specification as HTML integration point. Maybe I will I will open the HTML specification. So HTML standard, maybe multi-page. And here we have the parsing section. Okay, something in here. And we will have the HTML integration points. Okay, so foreign object is an HTML integration point in SVG, desk, and title. 3 elements in SVG can make the child element switch namespace from SVG to HTML or Math. Okay, so let's see that. If SVG has a child, for instance, title, then the child is in HTML namespace. And this is actually, or there are actually the only 3 ways that elements can switch namespace from SVG to another namespace that are children of SVG. Now let's have a look at Math. And in Math we have another set of elements that are called Mathml text integration point. So here we have Mathml text integration points, and there are mi, mo, mn, ms, and mtext. And these elements can also make the child elements to switch namespace from Mathml to HTML. So for instance, once again, by default, the canvas that is a child of math has a math namespace. However, if I add the mtext in here, which is the Mathml text integration point, then this child is in the HTML namespace. So ntext made the child switch namespace. Interestingly, two of the HTML integration points are also Mathml elements. So let's have a look at that. So one of the HTML text integration point that is in the Mathml namespace is called Annotationxml. So let's have a look. Let's say that I will have the canvas element in here. And as you can see, the canvas is in Mathml namespace, not in HTML namespace. This is because Annotationxml is an HTML integration point only if it has the attribute encoding equal to either text HTML, and now the canvas is in HTML, or application XHTML plus XML. I have no idea why it was specified this way. It just works this way, and well, all browsers and other parsers implement it. Oh, hello Mario, nice to see you in this video. Okay, moving on. So we have the Mathml text integration point and we have the HTML text integration point. In fact, Mathml text integration points are a little bit more interesting in bypassing sanitizers. Because when I have the Mathml text integration point, and from now on I will always use mtext, because I believe that it is quite easy to comprehend that Mathml text integration point is called mtext. So it makes a lot of sense. And basically all the children of mtext or other Mathml text integration point will be in HTML namespace, like s, like div, like paragraph, like anchor. But there are two counterexamples, and these are mglyph and malign mark. Again, I have no idea why it is specified this way. It just works this way. So A is in HTML namespace, but on the other hand, mglyph will be in the math namespace. And see that if I add a canvas in here, that even though canvas is a child of mtext, not a direct child, but it is a child of mtext, but by default elements inherit the namespace of the parent. So because mglyph is in math namespace and it is not Mathml text integration point, then canvas is also in math namespace. This is going to be pretty important in a second. Okay, now let's talk about next thing. So I'm going to alter the parser here. So I'm going to parse the initial string, then I'm going to serialize it. So I'm going to assign it to a variable. And after serialization, I'm going to parse it again. So I'm going to create a new document and parse it once again. And also display. Okay, now let's add some markup in here, like hello. And as you can see, if I have a DOM tree and I serialize it and then I parse it again, it might seem intuitive that the second DOM tree will always be equal to the first DOM tree. But this is actually not true, and it is possible to create a DOM tree that when it is serialized and parsed again will return a different DOM tree than the original one. And actually HTML specification gives us an example. I hope that it was, yes, it is in here. Okay. But before going to that example, one more thing. Form element is also special in HTML specification because you cannot have form element that is a child of another form element. As you can see, I created 2 form elements in here, but only one appears in the DOM tree. The second one is completely deleted. But there is a way to make the form appear in another form. So what I need to do is I need to create a misnested tag. So the form needs to have a child. It doesn't matter what element that is. And after opening this child, I'm just closing a form and then I'm opening it again. So here I have form, div, and another form. Even though it was not allowed in the ordinary markup, it is allowed with this trick. And this trick is actually given in the HTML specification, which is quite interesting that we don't need to think about it by ourselves. Okay, and what is interesting is that when this DOM tree is serialized, then we have a normal, an ordinary embedded form. So we have form, then div, and then opening of another form, which means that this second form is not created. So the first DOM tree has 2 form elements, while the second DOM tree has only 1 form element. So this is an example that we can create a DOM tree that after serialization and reparsing is different from the initial one. And there is also another example, which is kinda interesting. When I create a table and then I use some element that is not specific to tables, like just text notes. Okay, it is not seen, sorry, it is not seen in the DOM tree. But what is interesting in parsing is that even though this letter A appears to be inside table, and after parsing, they are actually before table. It will also have some consequences, but we will talk about this in a second. Okay, so now let's see what's going on. Let's go back to DOMPurify. Maybe I will open the source code on GitHub. There will be something like that. GitHub cure53 DOMPurify. And let's just see how DOMPurify works from the inside. And so to parse the HTML, DOMPurify uses DOM Parser. This is an API that is exposed in JavaScript that can be used to parse a snippet of HTML to a document. So this is exactly the same API that I am using in here. So when I enter some markup, like maybe even form, then DOMPurify sanitize it using DOM Parser, and then it looks at body. We can see it somewhere in here that in the default configuration, DOMPurify only iterates over body. So it iterates over all children of body and decides whether this element or attribute is in an allow list or not. This has an interesting side effect because if you use a style element at the very beginning of your markup, then it might seem that DOMPurify disallows style because the sanitized string doesn't have style element. However, the truth is that style element was actually created in head. And because DOMPurify iterates over body, it just doesn't see the style elements that is in head. So if I add any character in here, like for instance X, then it is parsed differently and then the style is in body, and now we can see that DOMPurify allows a body. So if you ever was looking for some bypasses in DOMPurify and you enter style at the very beginning and you couldn't see it, so this is the reason why this happened. Okay, moving on. So DOMPurify iterates over everything in body and then deletes what it deems dangerous. So for instance, on error attribute. Then DOMPurify sanitizes it, and we can see how it is parsed by the DOM Parser again. So The problem is that, as you already know, it is possible to create a DOM tree that is different after serialization and reparsing. So let's see that. So I am going with this form trick. Okay, so in this case, DOMPurify returned a string that includes 2 forms, but after it is parsed again, then we have only 1 form. Maybe I'm going to change the code so that it more closely resembles what you usually see with DOMPurify. So I'm going to create a div in here. So document create element div. And I am going to assign the sanitized content by DOMPurify to the div inner HTML. And then I am going to display this div, so that all those head and body elements are no longer visible. Okay, so the sanitized string has 2 forms, while the second DOM tree has only 1 form. Okay, and there is also one more thing that I forgot to mention, and I need to do it right now. That when I'm in foreign content, like in SVG, there are certain elements in HTML specification, and these elements are, this is the list of these elements. These elements are just closing the foreign content. So if we are within SVG, then this SVG is closed and this element is created in HTML namespace. So one of these elements, for instance, is div. So let's see. I have SVG, and it may seem that this div is a child of this SVG. However, because of this rule in HTML specification that I showed you, the div actually closes SVG and is created in HTML namespace. The exact rule is that we keep popping more elements from the stack until the current node is either the text integration point, HTML integration point, or just an element in HTML namespace. So I can add div if I am in the HTML integration point, like in title, but if I create a div directly in SVG, then, well, SVG is closed. Another example of this kind of element is paragraph. So this paragraph cannot be a direct children of SVG. It is just not possible to create a markup that makes the paragraph happen directly within SVG. So yeah, let's see something else. So I'm going to give you a counterexample to what I just said. And I'm going to open Safari because Safari still has some kind of parsing issue that other browsers don't. So paragraph is also quite specific because of one other feature. Most tag, when I add a close tag or end tag for these tags, they are basically ignored. So when I add an end tag for div, but div was not open before, well, it is ignored. And this happens for most elements. With two counterexamples, that is, well, it doesn't work in this case. Okay, maybe I will try to use DOM Parser. Okay, in DOM Parser it works. So have a look that I created an end tag for paragraph, so there is no closing tag, no start tag, sorry, but the paragraph is still created in the DOM tree. And the other tag, the only other tag, is BR, so the line break. So we have these 2 tags that we can use the end tag without the opening tag, and then actually an empty tag is created. Pretty crazy, but this is how it works. And there was an interesting parser bug in Safari and Chromium, but it still exists in Safari and was fixed in Chromium, that when I have SVG, and then I have an end tag for P, then this paragraph is created within SVG. So have a look, when I try to open P within SVG, then, well, it is in HTML namespace. But when I try to close p within SVG, then it is a child of this SVG. And this is actually a root cause for a DOMPurify bypass that I found like 1 year ago. So let's see what happens. I'm going to load older version of DOMPurify. So let's see what happens in here. So I'm going to close the paragraph, which happens to be inside SVG. And as you can see, DOMPurify, after sanitization, serializes this DOM tree, and now the P is inside SVG, which means that after second parsing, the P is going to be outside SVG. So basically everything that happens after this paragraph will be parsed differently. For instance, the anchor, which originally is in SVG namespace, after serialization and parsing is in HTML namespace. So this is a perfect place to abuse the differences in parsing of style elements between foreign content and HTML. So I add a style, and in SVG style can have children. So I'm going to add an anchor in here, then I close the style, and then I'm going to add the typical XSS payload. And yeah, DOMPurify decided that, well, this DOM tree is perfectly fine because we have SVG element, it is an allow list, P element, it is an allow list, style is an allow list, anchor is an allow list, and well, the title attribute is harmless. So it is serialized to this form, but when it is parsed again, then this P suddenly closes the foreign content, and everything that follows is parsed in the HTML namespace, which means that this style is now closed right over here, and the image tag is created in the DOM tree. So this is a bypass that I found like 1 year ago. And the root cause was a parser bug that made it possible that an HTML namespace element was a direct child of foreign content element. So this could be either SVG or math, and we can use either P or BR. It didn't happen to any other element. Okay, so let's stop cheating and hide the Safari and go back to Chromium. Yes, this bug was fixed in Chrome 77 or 78, I don't remember exactly. The truth of the matter is that it was a bug in the HTML specification. I mean, both Chromium and Safari just follow the specification, and well, the specification said that when we have a end tag within SVG, then it should be a child of this SVG. And this, I guess there is a ticket in the HTML standard that it should be fixed, but I guess it was not fixed in the specification so far. I just think so, maybe I'm wrong. I will check on that later. Anyway, let's go back to another bypass. So I'm going to use this trick with forms. So I'm creating the form, then math, and the Mathml text integration point, which means that all elements that are inside mtext will be in HTML namespace, besides mglyph, which is going to be in Mathml namespace. And then I'm going to use, okay, before mglyph, I'm going to use closing of form and opening of form. And what happens in here? So I have form, math, mtext, end tag for form, and start tag form, and then mglyph. So initially, we have embedded forms, which means that this form is in HTML namespace, and mglyph is also in HTML namespace because it inherits the namespace. However, after reparsing, the second form is now gone, which means that mglyph is a direct child of mtext, which also means that it is in Mathml namespace. So the idea is that I can use style which initially is parsed in HTML namespace, but after sanitization, after serialization and reparsing, it is in Mathml namespace. So image is another example of an element that closes the foreign content immediately, but the DOM tree that DOMPurify works on, well, has the image tag just as a text. However, after this form tag is gone and mglyph is in Mathml namespace, oh, why is it deleted? It is not the right version. Let me check it again. Okay, update parser, the alert was visible. Okay, so now the mglyph is not in HTML namespace but in math namespace, then style is also in math namespace, which means that the image tag suddenly closes the foreign content and is created in HTML namespace. This is the XSS that was called the namespace confusion, because we have a perfectly fine DOM tree in the beginning, but after reparsing, the second form is deleted and these elements have different namespaces. So there were also interesting variants of this particular bypass. Almost immediately after the one with form was fixed, another one was found using table. So here's the same idea. Mglyph is seemingly a child of table, but actually the table is after mglyph, which means that initially mglyph is in HTML namespace, but after reparsing, mglyph is in Mathml namespace, which makes the style tag being parsed differently, and image tag then shows up in the DOM tree. And then there was an interesting bypass by I need to like by Daniel Santos. So I'm going to find his write-up. He also abused the same idea, so namespace switching, but there was a switch from different namespaces. Okay, so there is a write-up about this particular issue. Okay, I think I can just write it from memory if I remember it correctly. So here the idea was that I create another form trick, but then the child of mglyph is svg, which means that this svg is in svg namespace because its parent is in HTML namespace and svg makes the namespace switch. However, after reparsing, svg is in Mathml namespace. So let's have a look what happens right now. I'm going to add mtext. So now mtext is in svg namespace because its parent is svg. But after reparsing, mtext is, well, in Mathml namespace. So it means that this is the Mathml text integration point. So once again, I can have a style. And initially the style is in svg namespace, but after reparsing, it is in HTML namespace. Which means that I can use a trick that I can create another element, and this element has end tag for style in an attribute, and then an XSS payload. So this is the DOM tree that DOMPurify works on. It is perfectly fine. All these elements are in the allow list, so it is then serialized, and after parsing it again, while the style element, which was initially parsed in SVG namespace, is now parsed in HTML namespace, which means that this style is closed in here. So the image now appears in the DOM tree. And another interesting bypass was by the Grand Pew, if I pronounce it correctly. And here it comes. There were a few bypasses. Maybe I will show with the headers. So he abused the behavior of header elements in HTML, that is h1, h2, h3, and so on up to h6. So basically, one header element cannot be a direct child of another header element. When I try to insert h2 as a child of h1, and then as you can see, the h1 is actually closed and h2 is a sibling to h1. However, if there's another child of h1, so h2 is not a direct child of h1, but just a child of h1, well, then it is allowed. But then, a very interesting thing happens if I have a misnested tag in here. So I open anchor before h2, but then I close it immediately after. And something really weird happens in here, that this A element is open before h2 and then closed before h2, and also another anchor is open inside h2. So as you can see, after serializing of this DOM tree, well, h2 is a direct child of h1 again, which means that this DOM tree is once again different before and after serialization. So here the trick, well, I am not really sure what was the trick. Sorry, I need to remember. There was a tweet with this trick. Okay, I remember right now. So the trick was once again to abuse math and text and mglyph. So originally the mglyph is a child of h1, and because h1 was in HTML namespace, then mglyph is also in HTML namespace. But after reparsing, the mglyph happens to be a direct child of mtext, which means that there is a namespace switch, and this is exactly the same idea as I have shown before. Okay, so there are a few issues that are a bit different, but I would argue that they actually have the same root cause. So basically the root cause are elements that happen to be in a wrong namespace. For instance, mglyph is in allow list of DOMPurify. Maybe I will show you the allow list of DOMPurify. Okay, here we have the Mathml, and for instance, mglyph is in the allow list for Mathml. But DOMPurify didn't actually check if the namespace is correct. So I could add an mglyph in the HTML namespace, and well, because mglyph as an element name was allowed, then mglyph in HTML namespace was also allowed. Now, if we enforce namespaces, and if this mglyph didn't happen to be in the HTML namespace and was deleted, well, then this exploit would not work. So that was my idea for a fix of all these issues that I have already shown. So maybe I'm going to show you the commit or the pull request that I did. So I decided to not only be on the attacker side, but also on the defender side. And I contributed a patch to DOMPurify, whose main purpose was to check if an element is in the right namespace. So basically, if we have an element that is in SVG namespace and its parent is in HTML namespace, well, then the only way to switch from SVG to, from HTML to SVG is via SVG element. If it happens via any other tag, well, then it should be killed. Okay, another example is that if we want to switch from Mathml to SVG, then the only way is that if the parent is either Mathml text integration point or Annotationxml, and the tag name is SVG. If it happens via any other tag, well, it should also be killed. Maybe I will go at the end. So if current element is in HTML namespace and parent is in SVG namespace, then the only way to switch from SVG to HTML, oh, the comment here is incorrect. Okay, I would have to. I'm not sure if it was fixed in next commit or not, but I need to check it. Okay, the only way to switch from SVG to HTML is via HTML integration point. So when I am in SVG and I want to create a child element that is in HTML namespace, well, then I need to use the HTML integration point, like for instance, foreign object. So going back to Safari, when I have SVG whose direct child is element in HTML namespace, well, then it is killed by this snippet of code that I have shown you, because element with HTML namespace cannot be a direct child of SVG namespaced element unless it is HTML integration point. Okay, and the final check that is being done in here is that we check if element is specific to either Mathml or SVG, and if an element is specific to SVG and it happens to be in HTML namespace, we also delete it. So for instance, foreign object is allowed, but if we have foreign object in HTML namespace, then it should be deleted. Another example is desk. It is also an element that should only be allowed in SVG namespace. So maybe I will load the newest version of DOMPurify. It was 2.2.6, I believe. And now let's see that. So I have SVG and then I have the desk element. And well, the desk element is allowed because it is in SVG namespace. However, when I have desk in HTML namespace, then the sanitized string doesn't have it because it is in unexpected namespace. So I hope that this fix is going to end this kind of issue once and forever. I am not really sure. There might, of course, be some bypass, and I will be really happy to hear if someone find a way to sneak an element besides this protection. But I believe that now it should be much harder to exploit this kind of issues. So now DOMPurify from version 2.2.6 verifies whether elements are in an expected namespace, and if they are not, then they are deleted. But this is actually not the only issue that was fixed in my pull request. That was another issue that I didn't have a chance to make public yet, but I'm going to show you it right now. And maybe I will open Firefox, because the difference that I'm going to show is much more clear to see on Firefox. Okay, so we have two parsing modes of HTML. We have the document parsing mode and we have fragment parsing mode. And what is document parsing mode? Well, document parsing mode is what we see right now. I can input a single character like X, and the resulting DOM tree has some elements like HTML, head, and body. Even though I didn't mention them in the markup, they are still created. Well, this is because this is the document parsing mode, and certain elements must be in the document. There is also a fragment parsing mode that is used if we use the inner HTML of some elements or insert adjacent HTML and some other methods. So in this case, when I enter a simple X letter, well, then we have just a text node with the X. There is no body, there is no HTML, there is no head, because it doesn't make sense to insert some a body element as an inner HTML of div, for instance. The fragment parsing algorithm actually have two parameters that are not exposed to JavaScript. So we have the markup that we want to parse, but we also have a context. The context is important because we can assign to inner HTML of different elements. For instance, let's create a div. And then let's create a style. And well, when I assign something to inner HTML of div, well, it is just parsed as an HTML snippet. Firefox doesn't show the DOM tree, so I can check just the inner HTML. However, when I have style, then as you already know, everything that is inside style is treated as text. So the fragment parsing algorithm needs to know the context so that it knows how it should be parsed. As you can see, this snippet was not parsed as HTML, but just as a text. Okay, and I have already shown you that DOMPurify uses the document parsing mode because, let me go back, uses document parsing mode because it uses the DOM parser, and DOM parser parses the whole document, so this is the document parsing mode. But when I have a look at an older version of this file, then even though DOMPurify still uses the DOM parser, there is also a method that is called insert adjacent HTML used. And this method parses the HTML in fragment parsing mode. So it is parsed a little bit differently than in the document parsing mode. And what is the difference? I'm going to show you one very important difference. So there is a snippet in HTML specification that is actually implemented only in Firefox, and I am not aware of any other browser implementing it. So we have that list of text that immediately close the foreign content. But the foreign content is not closed if we are in fragment parsing mode. This is what the fragment case means in this case. Okay, and let's see that. So we have the DOM parser, and I have SVG, and then I try to create a div element within SVG. Well, then the div element closes the foreign content and is created in HTML namespace. On the other hand, when I assign to inner HTML, which means that now a fragment parsing mode is used, then the div is created in SVG namespace. So we have a quite important difference in parsing in Firefox between document and fragment. Because if I was somehow able to convince DOMPurify to put paragraph inside SVG, then after reparsing in the document mode, well, the P will be outside of this SVG. So, well, this looked pretty interesting, and now let's see how it can be exploited. Because we need to somehow force DOMPurify to use the insert adjacent HTML. And the insert adjacent HTML is actually used if we delete some element. Let's have a look. Let me go back to an older version. So DOMPurify attempts to keep content of elements that it deletes. So let's say that I have an element called XSS in here. And then this element XSS is deleted, but its content is preserved. This is where the insert adjacent HTML is used. Okay, so if I create at the very beginning an element that is deleted by DOMPurify, then the markup that is inside that element will be reparsed in the fragment parsing mode. Okay, so we are going to mix a few tricks that I have already shown. So I am going with the, maybe go back to DOMPurify. Okay. So I am going again with the form trick. So form, math, mtext, closing form, and open form. And then we have mglyph as usual, and then plain text. Plain text is quite interesting tag in HTML because it is the only tag that you cannot close. Even if I try to use the end tag for plain text, then actually the end tag for plain text is in the text node of this plain text. So everything that follows the start tag for plain text is just treated as text. There is no way to close the plain text. However, let me see. Oh, the plain text is deleted. I'm going to simulate what DOMPurify is doing right now. So I will assign the document to a variable that is called a doc. And then I will delete the element called XSS. So doc query select.xss. I'm going to take its HTML. So cons HTML is XSS inner HTML. And then I will do the insert adjacent HTML after end. And then HTML, and then I remove the element. And at this point, I am going to display the document after removing XSS. And nothing happens. Okay, because there is no XSS element. So I put the XSS element, for instance, here, and then DOMPurify initially will see this DOM tree, but after removing XSS, the DOM tree looks quite a bit different. So I'm abusing the fact that the second form will not be created after reparsing, which means that mglyph will switch namespace from HTML to math, and then plain text will switch namespace from HTML to math, which also means that while in HTML plain text cannot be closed, then in math it can be closed. Which means that everything that is after plain text, after the end tag for plain text, will be reparsed or will be in the DOM tree, even though initially it is only a text node. So for instance, I can create a paragraph in here. And as you can see, this paragraph is in the DOM tree, even though it is initially in a text node. So this is pretty nice trick. And as you can see later on, the P element is now in the HTML namespace instead of being in the math namespace as it was before. So here's a pretty standard trick. I am going to open and close the paragraph, and then I can use the image tag. And okay, it doesn't work. Let me think. Okay, because it shows up. Sorry, that would be too easy. Let me think for a while. Okay, style is created in Mathml namespace, so I'm going to use the usual trick that I'm going to close style in an attribute. Let me see. Okay. So what happens right now, that this is the initial DOM tree that DOMPurify parses with DOM Parser. Then XSS is deleted because it is not in the allow list, which means that everything that follows is reparsed. So after reparsing, that is after removing XSS, DOMPurify works on this DOM tree. Well, this DOM tree is still safe. However, because there is a difference in parsing between fragment case and document case in Firefox, then this P element is created in math namespace, but after reparsing, this P element is created in HTML namespace, which also means that all elements that follows are created in HTML namespace. And this example is actually exploitable only if the result of DOMPurify sanitize is assigned to the attribute sourceDoc of iframe. Because sourceDoc of iframe is parsed in the document algorithm, while inner HTML is also parsed in Fragment, so nothing would happen in this case. But if you assign the result of DOMPurify sanitize to srcdoc of iframe, then it would work. We can check that. We can create an iframe, document create element iframe, and then iframe srcdoc is equal to sanitized. And then I am going to add this iframe to document body. And after this iframe is loaded, I'm just going to display its DOM tree, so content document. Okay. So I'm going to update the parser. We can see that the alert is shown right away. And in the beginning, I believed that this issue is only exploitable in Firefox, but then I found a bug that I shared on Twitter today with a simple, maybe not simple, but a quick XSS challenge. I noticed that there is a bug in Firefox and Chromium with serializing Noscript. So let's have a look. Or maybe we can do this on this version. So I have a Noscript element. And Noscript element is quite interesting in HTML because it is parsed differently whether you have scripting enabled or disabled in your parser. But let's see what happens. Maybe I will open another tab of LiveDOM and I am just going to show you the serialization. So once again, I'm going to assign the DOM parser result to a doc and then display the serialization. So document element outer HTML. And then update parser. Okay, and now let's see what happens. Maybe I will just serialize body because this is going to be more legible. Okay, so I have a Noscript. And now let's have a look what happens when I use the HTML entity and LT in Noscript. Then it is serialized to a normal end tag for Noscript. So this is a pretty big serializer bug, to be honest. And it means that we have a content that is initially a text node within Noscript, but after Noscript is serialized, then this image happens to be outside of that Noscript. And what is interesting is that exactly the same bug is in Chromium and Firefox, but not in Safari in this case. So Safari does it the right way. We can check that. Maybe I will open Safari. And as you can see, the serialization in Safari is correct. So this is pretty interesting why both Chromium and Firefox made exactly the same mistake. But now let's see how it makes it possible to bypass DOMPurify. So I am creating SVG, for instance, in this case. And within SVG, I will have the XSS element that is going to be deleted. Yes, I know that it might be a little bit surprising that Safari does it right as opposed to other browsers, but it really happens in this case. Anyway, I have the XSS element, and then I will add desk and Noscript. Okay, maybe I will copy from my Firefox the code that was supposed to delete the XSS and show what happens after the XSS is deleted. Okay, and I will not assign it to iframe, but to a div. Div inner HTML is equal to sanitized. So this is the usual usage of DOMPurify. Okay, so in the Noscript, I can embed a closing of Noscript. And let's have a look at it again. As you can see, the underline is initially in a text node for Noscript, but after removing XSS, so after this is reparsed in a fragment parsing mode, then the UTag suddenly appears in the DOM tree. And what I can do right now is that I can close the HTML integration point that is desk. And now Chromium is in a difficult position, we might say, because, well, the rule is that certain elements close foreign content. So for instance, paragraph closes the foreign content. But because the insert adjacent HTML is used on desk, then P cannot actually escape SVG. It cannot be done because, well, for instance, if you enter something as div inner HTML is equal to some markup, then, well, you don't expect that this markup is going to escape this div. So because the insert adjacent HTML is called on desk, it means that we cannot actually escape its parent element, which means that this P is once again created as a direct child of SVG. So we basically now have our old bypass, but we just need to craft it. So here we have the paragraph, then we are going to open style, then open anchor with title, close style. Let's see if it works how it should. Yes, it does. Okay, I'm not showing the div inner HTML. Okay, so I can finish the payload with the image on added is equal to alert1, and the alert appears. So what's going on? To reiterate, we have SVG, we have the XSS element which is going to be deleted, and the inner HTML of this XSS is going to be parsed again in the fragment parsing mode, which means that the P element is going to be a direct child of SVG. So even though initially style is in SVG namespace, after reparsing, this P is going to close foreign content, which also means that style is in the HTML namespace. So yeah, this is pretty crazy, I must admit. I tried to have a look if there are any other elements other than Noscript that has such a serialization issue, but I didn't find any. But it doesn't mean that in some cases this issue would also appear. But yeah, this payload is actually pretty crazy because it is safe. It is safe initially because everything that is dangerous actually is just a text node. But after removing the XSS, after reparsing in the fragment case, well, crazy thing happens and the image tag is actually in the DOM tree. And I found it purely by accident. I'm not really sure how I got the idea to check for Noscript, but well, it worked. And yeah, I hope that this bug is going to be fixed in browser, because I reported it to both Chromium and Firefox. And the first response from oh, okay, there is needs feedback for me, so I will do that. Anyway, they decided that Chromium doesn't consider this a security bug, since it would only cause Sanitizer to miss a pattern, but doesn't allow for any direct exploit. So I'm not sure if we can expect that this is going to be fixed really soon. And yeah, anyway, DOMPurify is not vulnerable. right now in the newest version, because the second change that I did was to get rid of insert adjacent HTML. Because we don't want fragments of HTML to be reparsed in the fragment parsing mode, because it can be dangerous. I have an idea for one payload, but I guess that you guys would be now checking for other payloads using similar idea, and I'm pretty sure that there would be some. So I decided that we just need to get rid of insert adjacent HTML. And now the idea is that we just iterate over all child nodes of the current node and just insert them manually. So this issue should be, completely gotten rid of. Okay, so I guess that's it. I hope that this stream was interesting, and especially the second part, because there were payloads that I didn't show yet. By the way, I'm going to publish a blog post in a while about the first part of this video, and I didn't have chance to write a post about this second part because I thought that the Noscript issue is going to be restricted in the Chromium backtracker, but while it is not right now, well, I believe I can publish the blog post like in a few days. And yeah, anyway, you will still be able to read about these issues in coming from the namespace switching. So I hope that you will find that interesting. And the question is, have you looked at the Sanitizer API in Firefox? It looks pretty promising. The answer is yes. Yeah, I agree that it looks pretty promising. And as Mario says, they have the namespace checks from the very beginning. But actually, one idea that I have shown you also works on Firefox Sanitizer. There is a, I guess, not yet fixed bypass for Firefox Sanitizer, and you could recreate it from what I've shown in this video. This might be your homework. So, yeah, but other than that, I believe that it looks pretty good, and I'm really interested if any bypasses are going to come. So, okay, I will change the camera. So, hello again. So this is all that I had to say. If you have any questions, you can ask in comments after this video or ask me on Twitter. You can see my Twitter handle in the background. So thank you very much for your attention. Have a Merry Christmas and many bypasses of sanitizers or other security controls that you might want to bypass. So thank you very much. Have a nice afternoon and evening, and see you soon in maybe next live streams if you enjoyed that one. So thank you and goodbye.